we have a vector field, and I just realized I wrote it wrong. So we have a vector field, and what do we know about the vector field? We know that the curl of f is equal to this vector field right here, and we want to find the line integral around C with counterclockwise orientation of f. Okay, where C is a circle of radius 1, centered at the origin in the xy plane. Okay, so the idea here is that we want to use Stoke's theorem. So Stoke's theorem says that the integral over a surface S of the curl of f, this is a line integral of a vector field, this is equal to the line integral around the boundary of the curve, the boundary of the surface with positive orientation, or orientation consistent with the orientation of the surface, f ds. Okay, so in this problem, this is the thing that we want to find. Okay, but notice we don't know what f is, we only know what the curl of f is. So we're going to use Stoke's theorem to figure out to figure out what that integral is. Now notice in this problem, what are we given? We're given the curl of f, and we're given the boundary, or we're given the curve over which we want to find the line integral. In other words, the surface S is not explicitly given. So basically, we need to find any surface. We need to find any surface whose boundary is the circle of radius 1 centered at the xy plane. Now, one such surface would be the hemisphere of radius 1, the top half of the hemisphere of radius 1. Okay, but that's not the best choice. The most natural choice would be to say that the surface S is equal to the disk of radius 1. So I'll x, y, z is equal to 0. The disk of radius 1 centered at the origin in the xy plane. Okay, that is the most natural choice here. The boundary of that surface, the boundary of that disk, is equal to the circle of radius 1 centered at the xy plane. Okay, so what it means is that this line integral is equal to the surface integral over S of the curl of f, which is 0, x squared plus z squared, 8, over this surface. Okay, now remember, essentially by definition, a surface integral of a vector field is equal to the surface integral of the following scalar field. Here n is the normal vector. Okay, so I didn't say it, but C has counterclockwise orientation. Okay, so n is the normal vector of the surface. If the circle has counterclockwise orientation, this means n is pointing upwards. So the surface is a disk of radius 1 in the xy plane centered at the origin. So that means the normal vector for that is just 0, 0, 1. And so what this means is that this is equal to the surface integral of the function 8 over the surface. This is just ds. It's not vectors, just ds. Okay, and so this is equal to 8 times, this is equal to the surface integral of 8 over the surface. The surface is the disk of radius 1 centered at the origin. So this is going to be equal to 8 times the integral over S ds. But this is just 8 times the area of S. Okay, the area of S is going to be pi. So this is just 8 pi. It's pi because the circle of radius 1 has area pi. Okay, so this is how we do this problem. One step was having to determine what the surface was. We're given the curve. Now we have to figure out what the surface is. And in the next video, we will do a similar problem.